Hey there, thank you for joining us for the pre-event programming for the Data-Centric AI Forum. Dr. Pallavi Karant, you're going to give us a presentation beautifully put together around ontologies, FAIR principles, and dynamic data. So with that, the floor is yours. Happy to hear what you have to share with us.
Sure. Thanks, Woken. Yeah, thanks to Swamp community and Woken Melara. I'm happy and humbled to be part of this pre-event webinar, the Data-Centric AI Forum programming. Uh, yeah, let's see what's the topic for today. It is data dynamics, navigating the AI frontier with ontologies and FAIR principles. Just a brief bio about myself. I am currently a research software engineer serving at Technische Informations Bibliothek. It is known as TIB at Hanover. My passion has been into data semantics, understanding the basis, the meaning of things, and analyzing them. I have a fair bit of expertise around semantic modeling, verification, and building knowledge graphs from diverse data sources. I worked in various domains like healthcare, automotive industry, have solved various business use cases, which have been quite impactful in the recent years. Have worked on digital marketing content effectiveness, have worked on clinical trials in the healthcare domain, have worked on customer 360, mostly leveraging technologies like OWL, semantic web, and knowledge analytics. I have also worked on semantic search, interestingness. It's been my passion to design knowledge models and bring to life various knowledge graphs for insightful analytics. And earlier, I had designed algorithms for semantic centrality, distance, and various knowledge analytical algorithms. I hold a PhD in computer science and engineering from PES University, Bengaluru. And here we go, dive into the topic of the day, data dynamics, navigating the AI frontier with ontologies and FAIR principles. This is a brief agenda of what we are going to cover in the next 20 odd minutes. So we'll talk about data age, and this is the AI era. I'll give a brief overview of ontologies, what are FAIR principles, the synergies between dynamism of data, ontologies, and FAIR principles, business cases, the success stories, and we'll also see what's coming very soon, the next week on the 27th of March. So here is a cartoon. So this guy is politely requesting the other guy, here's a list of 100,000 warehouses full of data. I'd like you to condense them down to one meaningful warehouse. So this is the current situation in any business you take in any domain. There are umpteen number of warehouses. It could be personal data, it could be sales data, it could be marketing data, each one lying as a data silo or an island, not being able to talk to another. So this guy has this request to condense all of them together to get one single view of all the data into one meaningful warehouse, right? And we have yet another one there. So Mark tells Susan, the good news is we are getting lots of engagement on our AI generated content. And Susan replies, amazing, what's the bad news? It looks like most of that engagement is coming from AI generated traffic. So this gives us a thought, right? What should be made intelligent, what shouldn't be, right? There is a very thin line on what has to be subjected to artificial intelligence. And now there is this one which says the computer is claiming that its intelligence is real and ours is artificial. So in the recent days, we have heard of this term generative AI day in and day out. That is what is being talked about in the tech industry. So do we know what the generative AI is generating makes sense? Does it talk truth? Is it grounded in some logic? If yes, that is all good for us. But if no, what we need to do? How can we make it logical? How can we make it sensible? And we'll go into the details of how we can do that with ontologies and FAIR principles. So now coming to some facts, numbers, and statistics in the AI era. So as we know, go digital is the mantra, and in the last decade, all the industries have undergone severe transformation by making their data digital. So if we look at some of the numbers here, Statista report says by year 2023, we already had 120 zettabytes of data, and by 2025 would reach 180 zettabytes. And roughly the amount of digital data that is getting generated every day is around 2.5 quintillion of bytes, right? So it is roughly 10 to the power 18, 2.5 times of 10 to the power 18. So we know how much of digital data is getting generated every day. And if we look at the data interactions or making use of data services, it's happening every 18 seconds. Such a short span of time, we are having so many data interactions. And 97% business users already feel that generative AI will have something positive for their business. And this is according to Forbes. And 77% say data-driven decision making is very important goal for their data programs. And we have also seen that the data combinations or making some kind of interaction between the data sets has increased by 5,000%. So we already know we are bombarded by huge amounts of digital data, and it is now a challenge to integrate all of those data to make some sense, right? Now, we already have this dilemma, garbage in, garbage out, and this is intensifying day by day. So Monte Carlo data quality survey of this year says 50% of the industry participants said data quality is one major challenge for them when they are trying to handle data integration. And data can't be enriched consistently at scale. So what the context of the data, right? It is known to the business, but we have not made them explicit for machines to understand the data. And 66% already rate their quality of the organizational data as average, low, or very low. And we have 50% of organizations who have advanced data analytics, which are influencing their data strategy programs. Now we'll go through severe challenges which the data integration is facing. So there are a lot of heterogeneous data sources spread across in silos. So by heterogeneity, we mean the type of the data, the structure of the data. It could be static or it could be dynamic. It could be transactional in nature. The data is being placed in various traditional data warehouses, or it could be cloud databases or graph databases. So there is a lot of heterogeneity, and the context of the data, as I told, is not made explicit for the machines to be understandable. We already know there is big data that has to be handled. We rely on computational powers to handle such big data. So unless the context or the meaning of the data is made understandable, machine readable, it becomes very difficult to handle data integration. And data analysis in the traditional databases would involve complex joins that take a long time, and it is complex. And when we try to analyze the data, it is always better to consider the data which is already having the multidimensional characteristics. It is not just it does not fit into 2 dimensions, rows and columns. So we need to analyze multidimensional data, and our traditional data warehouses do not have the capabilities. And as we know, change is the only constant, and the new requirements keep coming. And whatever schema that these traditional data warehouses support is mostly static in nature. It is very inconsistent, and it will get incoherent over time. So now what is the solution? So we have ontologies and FAIR principles, which can help us navigate through these data integration challenges. So what is an ontology? I know it is within a short span of time to explain ontology. It is not very easy, but I will make a small effort in explaining what exactly is an ontology. So it is a conceptual understanding of a domain. So you can consider any hot trending topic of the day. So I think in the previous introduction to Swarm community, Walkin, you were talking about environment, right? So I will consider something which is very close to environment. What's happening today, the climate change, right? So let's consider this topic of climate change. So in this domain of climate change, what are the entities which you think would be important? It could be greenhouse gases, it could be carbon emissions, it could be global warming, it could be climate change itself, the impact, the causes for climate change, deforestation, what can we do about this climate change, afforestation, and some policies which are being made by several organizations. Several countries are taking part in devising these policies. And we can as well measure this global warming through several parameters. It could be increase in the temperature, and it could be renewable energy sources capacity. It could be carbon emissions, right? So we already saw, we got a mind map. When we are talking about climate change, we have a mind map within us, and this is telling how each entity in this domain of climate change is related to another. So if we make this mind map readable to machines, if we make this mind map understandable to machines, then that is what is an ontology. So it is a formal representation of knowledge within a domain. So it will help us to capture what is important in this domain, how each important entity is interacting with the other entity, what are the constraints on their relationships. So when we make all of these formal and machine understandable, that is what is called as an ontology. And in order to build an ontology, we have several knowledge representation languages, and all of them are standards from World Wide Web Consortium. We have RDF, RDFS, OWL, SCOS. We can get into the details of this sometime in future, or there is hundreds and thousands of material out there on the web to get into the details of these, right? So let's take another example to see what is an ontology. So this is an example from aviation industry. We have airports, we have aircraft, we have air traffic controller, we have weather phenomena, we have flight route, we have runway, we have aircraft manufacturer, and we also have the different relationship, how they are all connected to each other, right? So this is a pictorial representation of an ontology. And if we make this as a formal representation for machines to understand, then we have the ontology that any machine can understand. And now we'll go into the details of what becomes a knowledge graph, right? Here, the set of blue nodes that we have here is the ontology that gives the structure or an understanding for this aviation domain. Whereas the ones in the gray nodes depict the data, the real world data. So for example, here, BLR is Bengaluru Airport and FRA is Frankfurt Airport. And we have the flight route BLR to FRA, which is being operated by this flight AI234, and it gets operated by the airline carrier Air India, right? So we added data into this graph. This is the ontology, and we have the data in the gray nodes, and that together becomes a knowledge graph. And this will lead to many useful benefits by using it in any domain. So let me go into the benefits of ontologies. Semantic understanding. So we are able to not just understand for ourselves, but we are able to make AI systems or any machines understand and get the context of the data through ontologies. And as I mentioned, there are various challenges when we try to integrate the data from different data sources. So by having the context of the data, it becomes easier to integrate, and ontologies will enable knowledge integration. And the data is always mostly dynamic in nature. And as we know, knowledge keeps growing, right? It is not static. So how do we reason about it? How do we see that what gets into the knowledge graph is consistent and still holds a logical meaning, right? So ontologies support reasoning and inference, and it will enable us to have growing knowledge, that is to derive new insights out of the existing data. And data harmonization is a major challenge when it comes to integrating the data from several systems. So basically, the data would not be talking to each other. They do not know the context. And with the meaning being specified in the ontology, we would be able to integrate. Ontologies provide a basis for consistency and coherence in the data interpretation. And finally, we have it all. We have a trustworthy insight to be derived from the AI systems. So going back to that cartoon, so if we incorporate ontologies and FAIR principles, we would be able to get the insights which are grounded in truth. They are trustworthy. And now into FAIR principles. What exactly are these? FAIR basically stands for findability, accessibility, interoperability, and reusability. These principles were developed by the GoFair community. It was way back in the year 2016. It was mostly for the scientific and research data. The idea here was to enable data sharing and collaboration, right? If we have to foster innovation, if we have to foster multidisciplinary research, then the research data needs to be made shareable. The research data needs to be made interoperable. If the data sets can talk to each other, right? Which means that we can apply similar operations on the data sets, and they are findable, which means that they have some address. There is a unique identifier for the data set. We would be able to find the data sets of our interest easily. And if they are accessible through universally implementable open protocols like HTTP, HTTPS, and they are made interoperable. They all share some kind of common knowledge representation language, be it RDF or RDFS. And they are made reusable, which means that we can combine the data in various settings and get something useful out of the combined data. So FAIR principles basically enable all of these. And with this, with ontologies and FAIR principles, we can navigate AI frontier better. So let me go into this. So how we can have the synergy between data dynamism, ontologies, and FAIR principles, right? So if you look at data dynamism, so this is the current day data, what it is challenging, what are the needs of data dynamism. So in the current day, take any industry, data is ever evolving, it is scaling up, it is heterogeneous in nature, and there is always a need to get an entire perspective. And people do not want to look at silos and try to make sense of the entire data. They want to be able to see and get an entire perspective. So these are the challenges when it comes to data dynamism. And as we have seen, ontologies provide for flexible schema with the everyday changing requirements. Ontologies always support flexible schema. There is no standard schema that you need to agree upon on day one. And we can have the schema to be ever evolving. And the meaning or the context of the data is made explicit. So in this way, we are able to cater to the needs of dynamic data. We can do inferencing and reasoning, which means that we can scale up and we can get an entire perspective of the data. And data being multidimensional, it is becoming very easy to see or get an entire perspective. Let me share one example of a business use case wherein we can see how the data is multidimensional and how it helps to get an entire perspective to be able to derive meaningful insights from the data. And as we know, FAIR principles, they allow for the data to be found easily. They allow the data to be accessible through protocols which are well defined. They allow the data sets, the different data sets, to talk to each other, and we can combine different data sets. And hence, it would just foster more innovation, more multidisciplinary research. And this way, we would be able to navigate AI frontier with all three of them combined. So there is a synergy between all three of these, and I think every industry needs to go for this. And now going into the business case, right? The success story. So let me talk about customer 360. So be it any industry, we have customers and we focus on the needs of the customers and we try to cater to those needs, right? So let's take the different data that we have about the customers. We have the identity data, who a customer is, what is his address, and so on. We have the descriptive data about a customer. Customer can have his likes, preferences, what are the products that the customer likes or owns, what are the products that the customer is browsing and has still not yet bought. So this is all about the descriptive data of the customer. There is also the qualitative data about a customer. What kind of reviews has the customer written, right? It is not something which is measurable as a number, so it is qualitative in nature. We also have data about what prompts a customer to buy something, or what factors does a customer consider when evaluating a product, right? It could be ease of use, it could be portability. There are umpteen number of factors depending on the product that the customer is looking at. So we have a lot of qualitative data about the customer. We also have quantitative data. What is the average purchase amount for a particular customer, right? There are some CRM metrics available. So basically, we have different types of data about a customer. And there are different interactions that a customer would usually have, right? It could be that the customer is writing a review on Google, the customer is writing a review on Amazon, and it could be he's tweeting something about the product. So there are multiple social media platforms where the customer is putting his data out there and can be leveraged that data. There is also this purchase history of the customer. The customer would have some concerns and he would reach out to customer support systems, right? And even the customer support system will have a lot of information about the customer. Was the customer issue solved? How long did it take to solve that customer's issue? So there's a whole lot of data out there. They lie in different systems. There is also analytics data, how the data, how each customer is interacting with any online website or a platform, right? So they are all data silos lying there in different systems. And when we look at the type of the data or the structure of the data, it could be they are unstructured, they are semi-structured, or some data is completely structured, right? And there are different systems out there. So we could have CRM data from SAP, we could have Salesforce data, which talks about the sales. We could have the order management data from IBM Sterling's. We could have customer support data from a platform like Zoho, and we could also have analytics data coming from Google Analytics. So huge number of data sources, all data silos, they don't talk to each other. So what can we gain out of these, right? Unless we integrate all of these with a customer ontology, we cannot actually make any sense of them as data silos. So suppose we integrate all of them, the jigsaw puzzle here gets completely solved, right? So we have a customer ontology. There is a basis. What is a customer? What is a product? What is an order? What happens on the site when customer interacts with the site or on social media? So all of them are richly connected. It is just that this context or meaning needs to be made available to machines, right? For deriving some insight or getting sense of what's happening there for a customer and a product or a range of products, right? So we have everything connected here and the jigsaw puzzle is solved. So this is what we call as customer 360. It is a data product which allows any business to see or get the 360-degree view of customers, what's happening on the customer landscape, what we can do better, can we track the customer journey, can we personalize the journey for any customer. So this is what it is all about, customer 360. So it can be done through a customer ontology, building a customer knowledge graph, and trying to run several analytical algorithms, which basically tries to answer all the questions that any business can have, right? So yeah, this is about a success story. So this is how we can use the ontologies, the FAIR principles, and the knowledge graphs for success in any industry. It is always grounded in truth, and we have a logical basis for it. Yeah, so this is what I had to share on this topic. And now coming to the data-centric AI forum programming, right? So what's happening on March 27th? We have a whole range of topics in AI waiting for you out there. So let me try to go there. Let me get that link and
essentially we're going to be having programming around different use cases, different experiences that practitioners in the trenches have had working with data infrastructure from the perspective of ontology and FAIR principles, and how that has delivered tangible benefit to organizations that have adopted these knowledge organization systems. Um, Flavia, I think we have the link for the program underneath in the talk. So if anybody's watching live, they can click on that comment and they can look for further programming that's happening Wednesday of next week. But
yeah, I'm just trying to probably get there. I'm unable to click the link right out there.
we'll share it in the comments if it's not already there.
Okay, yeah. So there are a whole range of topics waiting out there, and it could excite AI enthusiasts. So here we are inviting you to get soaked in entire range of topics, maybe from generative AI to ontologies to enterprise knowledge graphs. So yeah, please make the best of it, and try to collaborate and make the most out of it.
Thank you very much, Dr. Pallavi. I think we're a whole lot richer. We understand the whole scope. The world is a fragmented place of jigsaw puzzle pieces, and we got to put the pieces together. And the way to do that is look at the box and use ontologies.
Yeah. Thank you, Woken. And if there are any questions, we'll be happy to take it here.
If you have any questions, even after the recording, what you can do is you can leave a comment on the video recording, and Dr. Pallavi can get to them when she has some time. So thank you guys for tuning in, and yeah, we'll catch you in the next one
Okay.
happening in 2 minutes. So see you soon.
Okay. Yeah. Thank you. Thanks for joining.